right about now. Beautiful. All right, lesson 2, practical C++ primer. Let's roll. Now, we do happen to have new students here and there, so welcome to all of you. For those who don't know, sign into this class. I like to keep a record of who is here and who isn't. There is some random letters here. They aren't really random. They actually stand for something cool. And they send those to me over Slack in a private message, so I know that you're here. It just helps me keep track and understand who is here and who isn't for attendance. So, good to go. All right, let's jump right in. Let's talk about assignments. So, this was a particular pain point for me because when I was working out this class and how it was going to work, in my head, this was going to be a class for my team, and everyone on my team knew C. Now, this was ridiculous because not everyone on my team knew C perfectly. And even at that, if anyone else wanted to join, it would become an issue in the long run. But this is how I planned it. And then more people who didn't know C joined the class, and then I got sick and I didn't have time to adapt. So by Monday, I kind of just left the class as was and hoped for the best as people joined. Unfortunately, what this meant was that not everybody understood the assignments as much as they should have, because I assumed everyone had a certain skill level. Absolutely massive skill parity in this class. We have people who know the C programming language, we have people who know programming, and we have people who have never programmed in their life before. All of these makes for a difficult way of balancing assignments. You now have to do something that I wasn't a huge fan of, something I didn't want to do at the start. We're going to be fragmenting assignments, which means a little bit more work for me, but we can work with that. So let's talk about that for a second before we go into what we're actually going to be learning right now. So I have 3 new versions of assignments. We have alpha, beta, and gamma track assignments. Darian, why did you say easy, medium, and hard? Because easy, medium, and hard aren't in alphabetical order. That's it, honestly. Okay? So, let's say that you've never programmed in your life before. You don't even know what the heck C is. Maybe you're like, this is a cool letter. Let's use my favorite letter. And C++ must be better because we're adding things to my favorite letter. Alpha track assignments are where they're at. This is what you want to do, and these are the ones you want to do. Let's say maybe you've done some programming before, or maybe, welcome aboard. Maybe you've done some programming before, or maybe you thought assignment 1 was easy and you've never done your programming before. That's fine. Beta track assignments are for you. And maybe you've done C before. And maybe you're looking for a challenge. You know, you're going to put some time in outside of class just to learn these things before I teach everyone else as thoroughly. Gamma track assignments are for you. So, in addition to that, assignments are given out at different times as well. So alpha track assignments given out once every 2 weeks. So the first assignment I gave is an alpha track assignment. So that isn't due today. It's going to be due not next week either because we have Memorial Day. So everyone has 3 weeks for assignment 1. Good on you. Beta track assignments are given out once every week. And gamma track assignments are given out once every week, and they're more difficult than beta track assignments, which is why this little plus. You're not getting more than one though, so I don't know what it is. I just like pluses. Anyway, so let's go over. Let me just show you how that's laid out in here. So I'm going to go to darianglasser.com/DPP. You've probably all been here before. I hope so. We're going to do assignments and slides, where all our assignments are located, and all our slides are located as well. And we're going to go into assignments. And here you're going to note there are now 3 folders, not just 1. This is why it's critical they're in alphabetical order, because then I don't want people looking for the medium assignments and being like, why is the difficult assignment in the middle folder? It's not a thing. So if you look in the alpha assignment, you can see the assignment that I assigned last week. And if you look in beta and gamma, you're going to see more difficult assignments. Beta is more in line with if you got an idea with what happened last week, and gamma is in line with what we're going to be going over today for about 15 to 20 minutes. So you're expected to put some time, extra time in for those. And of course, like I said, just like how alpha assignments aren't going to be due on Monday, neither are the other 2. They're going to be due the following week because we have Memorial Day off, aka no class. I'm sure people have plans or something, and I don't want to encroach upon those because that's the thing. In addition to these, sort of like a reward for completing assignments, you get I'm going to make a sort of certification for if you can follow along with any of these. So if you can finish so many alpha track assignments or beta track assignments, you're going to get a little certificate at the end of class saying that you did this. And if someone asks in the CubeSat satellite project what you got from the class, you can say, I got this certification from Daring Glass's class. Does it really matter? This isn't like a real class. It doesn't mean a whole lot. But it kind of does. It comes with the connotation that you put some extra time into this class and you did things. All right? In order to work out how these work, alpha track assignments are worth 1 point, gamma and beta is worth 2, gamma is worth 3, and that means if you're doing gamma track assignments, you technically slack off for X amount of weeks and still get alpha. But the thing is that you're going over stuff that's so new, you're pretty much doing the alpha assignment, so it doesn't matter to me. Finally, is there anything else to go along with there? Oh yeah, missing assignments can happen too. Your score, you're going to be given a score based off of these. So if you get a score of less than 0.8, based off of your total number, say like 3 over 4, you get that certification. Pretty simple. 80 is passing, and you have 3 levels of 80. Fine. Cool. So that's all there is with assignments. That's that. So let's talk about the real pain point of assignment 1, because I know that this was an issue where a lot of people didn't know how to build a class, and on top of that, I didn't really go over nomenclature of things inside of a class. We kind of just sped through it. So let's go over how to build a class. Let's actually build one from scratch, and I'm going to talk about everything I do here in great detail so we all understand how it works. So first, I'm just going to grab download our template repository. I still have a fresh copy. Go into release, and we're going to download this tarball. All right, we go to this. Get out of here, screen recording tool. Oh, I already have it. Okay, I already have this up. And we're going to go to downloads. I'm going to move. Let me just make this big. Just going to move template /code temp. Unzip it, CD template. Cool. Now let's start. So here we have, need to make this. Here we have our template repository, and once again, this is exactly what it looks like. I was pretty clear on how it worked, but sometimes things I say are missed if I don't say it enough. I want to say that in business, you're supposed to say something like 5 times before people really understand it. So let's just go over this real quick again. So when we're talking about the template repository, we have a bunch of different folders. We have our build folder, we have our include folder, and we have our source folder. Inside your source folder, all your C++ files should go. Inside your include folder, all of your header files should go. And inside your build folder is where everything is going to be built. All right? So let's go and let's make some C++ files and some header files real quick. So I'm going to go in, and I'm going to go into our include folder. And I'm going to make a header file. So, what is this name? What's it going to be called? Something descriptive. Descriptive.h. Okay. And we're going to make this right now. Yeah, get out of here. Close. And we have some screen tearing. No, do you mind? There we go. Good. So, descriptive.h. So let's make a class right here from scratch. And let's start. Let's make this bigger. We have the keyword class. This denotes that we're working with a class, and that's really all there is to it. We need a name for it. The name of a class is generally the same name as the file. You cannot do this if you don't want to. I'm going to be very angry if you don't, though, because it's a standard convention. We're going to call it descriptive. In addition, a lot of times the name of classes and the names of files are supposed to be capitalized. It's an oversight that I didn't, but you should do that. Fine. Then we have an opening bracket and a closing curly bracket. And finally a semicolon, because we always have semicolons to delimit lines. Awesome. This is the most base form of a class. It has everything we need to, and it's a great prototype for what we're going to be using to build things. Now, let's talk about the next 2 things we need. talking about access modifiers, and this is the official name for them. So, public, private. Anybody who remembers from last class, can you please tell me what public is and what private is, and what the difference is when we're talking about classes? Anybody know? Try not to describe well enough. Go for it, Silverio.
I'll try my best. I think anything on the public can't be accessed by the function, maybe. Anything in private can't be accessed by the people.
That's pretty close. So when we're inside of a class, everything inside of this class can be accessed, both public or private, but only by things inside of this class. Well, let's say you got a friend, other class. It can access the public methods, but it can't access the private methods. Those are hidden. So the analogy I used last week was that, say someone is building something really cool, maybe a plane, and it's difficult to build a plane. It's got a lot of moving parts. Don't want anybody to just go about messing this thing while it's being built. Okay? So you're going to build this. You're going to build it. You don't want anybody to do anything. If someone gives you a wrong wheel, you're screwed. It's gonna hit the ground and it's just not going to work. So you're going to build it in private. And then when it's done, people can ride in this plane. They can use the public methods to do so. All right? So this is why you want things to be private. You don't want other people to mess with certain aspects of your class. You only want to give them direct access to certain things. And this goes back to the idea of object-oriented programming, where we have the whole class diagram. But more importantly, that you can build something, and someone doesn't need to know how it works. They just need to know that it does work, and that this is how you're supposed to use it. Private methods are for how the class works. Public methods are how you allow other people to use that class. Silverio, go for it.
So by hidden, do you mean if somebody would have opened the file, they just wouldn't see anything?
No, that's not what I mean.
In the place of private,
What I mean is that if someone tries to go about writing a second class and they want to access parts of that class, they won't access the private ones. They can't. Now, sure, they can go into the file and they can change it to public if they want to. The problem is, if you listen to any decent programmer, they're not going to do this because this is really bad practice. Because they know that in their files, they don't want people messing up internal parts of their stuff. And if they do, just chaos all over the place. Now, you're not going to find this happen a whole lot. Chances are, if you make something private, you do so for a reason. You don't want people messing this up because it's internal to your class and they don't need it for any good reason. But that's the idea behind public and private. Okay? So let's make some access modifiers. I'm going to do public here. We do a colon to denote that everything below here is public. And then, at the top, I'm going to do private and another colon. That means everything from here to here is private, and everything from here to here is public. Now we get to choose what goes in here. Now, last class I talked about constructors. I didn't talk about constructors enough, though. Some people are confused about what constructors were, how they were meant to be used. So we're going to go over that real quick. So what is a constructor? One uses a constructor to go about building the class. All right? To build an object. So to go back to last class, we were talking about classes versus objects. A class is pretty much just the instruction set on how to build an object. An object is the actual thing that's being built. So you can have a class called car, and I can have a red car and a green car, and Nick can have a yellow car, and Dak can have an orange car. They're all cars. They're just different types of cars, and these are objects versus classes. So we need a way to build this. We need a way to construct it. We use a constructor. See? Smart. The way the constructor works is that it's a function, but it doesn't have a return type. And the name has to be exactly the same as the class name. So we can call this descriptive. And we're good. Once I get rid of this asterisk. Done. We have now officially made our default constructor. Now, we can go about making other constructors as well, and we'll go into that in just a moment. I want to go over data members first, though. Are there any questions so far? Yes, Becky.
Is it like an init function?
Yeah, sure. It's like an init function. Yeah, go for it.
Can you repeat the purpose of the constructor?
So, when we're working with classes versus objects, you know the difference between a class and an object? I think that's a note. So, we have a class. Oh, these are the bad markers. They look the same as mine, though. We have a class. It's sort of like an instruction set, sort of like a manual. You can go about reading it. This shows you what's inside and how it works. However, if we have an object, this is an instantiation of that class. So if you go to IKEA, I used this example last week. If you go to IKEA, maybe you want to buy a good table. You love tables. I have one in every room, sure. And you're going to open it up, and you're going to be given a manual. Usually the manuals are pretty funny. I like it. But that manual is not a table. You're going to use that manual to build one, though. So the constructor is pretty much the manual. The object is the table itself. Okay? Does that make sense? Cool. It's a common interview question, by the way, for base level programming. You should write it down if you don't know that. So now we have a constructor right here. Oh, wait. Any other questions? No. It's cool. Now we have a constructor right here. But this class is still pretty bare. We need something to store in it. We need a reason for it. So what I'm going to do is I'm going to put a data member in here. And what a data member is it's just a variable. It's a type that we put in there that can be accessed anywhere in the class and not necessarily outside of it, or not necessarily modified outside of it. This is an internal way of keeping data inside of the class. And we're just going to call this number. Okay? Despite the class being called descriptive, this is not a very descriptive class. If you're actually writing code, it should be much more descriptive than this, and your name should be much better than the ones I'm giving right now. That's not a thing. Alright? Now, before we keep going, if anybody's noticed, we don't have any definition for our constructor descriptive right here. All we have are an opening parenthesis and a closing parenthesis, and that's it. If we try to run this, it's not going to work. So what we have right now is just a description of what this is going to do, but it's not actually doing it yet. And we're going to define that in the C++ file. Nice. So let's go about making a way now that the user can go about getting that number without modifying it. So what I'm going to do is going to make a getter function. Okay? And it's going to return an integer, and we're going to call it get number. Done. Now this function doesn't have to do this, but because we named it as such, we're going to make it so it gets that number. And that way anybody can go about seeing what the number is if they want to do later. Now, this doesn't do so much yet, but it's a good time to start defining what these things do just so we can see what they do. So I'm going to open up a C++ file. And descriptive. So, your C++ file should have the same name as your header file. This is a great way to associate them, and if they don't have the same name, I'm going to be very angry, but it's still going to work. Just know you'll get a 0. So, what we're going to do first, we're going to include our header file because we can't build that table without the instruction set. So let's include that so we know what we need to do. Include descriptive.h. Notice how, unlike when we're including libraries that are already on our system, this one has quotation marks. This makes it different than including something like include IOStream, which is a library we use for printing. This has the opening, closing, greater. I still don't know what to call these. Greater than and less than signs. And comparatively, ones we define ourselves have quotation marks. Nice. Let's get rid of that for now. We need to build our constructor. So to build our constructor, we first need to reference our class. And the way to do this is we need to have our class name, 2 colons, and then we can have the function right after that. Because otherwise, it's not going to know that it refers to this function refers to the class. So we have our class name. Our class is called descriptive. So we need to do this. We need to type down descriptive. And then we need to do : : and now we know that we're working with a member from descriptive. We can start defining what it does. So we need a name, sorry. So we're going to call this descriptive. Because it's a constructor, this takes no arguments. We're going to do an open and curly bracket. Now we have a constructor. This is a default constructor. It doesn't really do anything yet, but it's there. What's up, Silveria?
So the first term before the double semicolons, that tells you what the class is, and then to the right of the semicolons is the function in the class that you want to use.
That's exactly it, yes.
Okay.
All right.
If we were defining what that function is.
Yes, we're defining what the function is right now. This is a special function because it's called a constructor. This doesn't have a return type because it just makes the class on its own. All right. So what I'm going to do is I'm just going to set the number that we have before, and I'm just going to set it to a default value. Let me just put these side by side so we can see. So we have this number right here. Because we have this number and it's defined in this header file, and we're defining what this class does right now, we can set this number even though it's private, because these two files are inherently linked. So I'm going to set number equal to, what's a good default value? Does anybody have any preference? Nope. 2? Oh, fine. 2 works. Okay. So now we're just setting number equal to 2. Cool. That's all a constructor does, and that's pretty decent for a start. Now we need a way to retrieve this number so people who aren't defined in this class can go about getting that number. Maybe it's useful. Maybe you need to know what 2 is for whatever reason. Becky, what's up?
Does it need a return type?
No. Constructors do not need return types. That's right, they don't. Yeah, think about it. Have you thought about it? I hope so. So constructors don't need return types. In fact, they can't have return types, and if you give it a return type, the compiler is going to get mad at you, as it rightfully should, because why would a constructor return something? It's not going to return something. So let's go about making our getter. So I'm going to descriptive : So we have this way we preface the thing with our class. We need a name. Our name is right here. It's get number. And now we're just going to have an opening and a closing curly bracket. What am I missing? Does anybody know? Oh, see, there we go. We're missing a return type. Now, if we don't have a return type, what's it going to do? The compiler is going to get mad when we try to compile this. It's not going to assume it's void. It's not going to assume anything. It's going to say, this person forgot a return type and this isn't a constructor. Get angry. So, the way we return this is the way we return just about any other variable. We literally just type return. And since we're not modifying this at all when we return it, we're just going to return number. Nice. Let's save this file, and let's make a main file so that we can... we want to do that yet? No. One more thing. Before we go about testing this code, I'm also going to make a second constructor, a way that a user can go about setting this number instead of just getting the default value of 2. Because really, 2 is a great number. In fact, it's my 3rd favorite number. But that doesn't mean it's a number we want to use every time we make this class. Maybe I want to make it like 8, or 12, or 49. I should have that possibility. So let me just make a second constructor. Descriptive. And I'm going to need to set this number. It's going to be an integer, so it's going to take an argument of an int. And I'm just going to give it a name, and we're going to call it input. The name here doesn't matter at all. In fact, if I even wanted to leave that out, I could. It just makes it easier for the developer who looks at this later to read, so I'm going to leave it on. And we're going to make a second constructor right now. I'm going to call it descriptive. We're going to do 2 colons. Now we know it's referring to this class. We're going to have the name of the constructor again. And we're going to have int input opening, closing curly brackets. Let's make this a little bit smaller so you can see all that. Then we just need to set the number equal to the input the user gave. So number equals input. Sweet. But Darian, it can't be that easy. But it is that easy. Now, what we just did here, before we go about testing this, we have 2 functions, and they have the same name, but they have different arguments. This one takes an integer. This one takes absolutely nothing. What does that mean? That's actually something in C++ and many object-oriented languages called overloading functions. If you do this in a language that isn't object-oriented, for example C, like when I first went into my C class, I couldn't do this and I was very angry. And you try to have two functions with the same names but different numbers of arguments, it's not going to work. The compiler will get mad. This is a feature in many object-oriented languages, and it's necessary for a trait called polymorphism, which just means one thing means many things. It's a fancy term. You're probably going to get it in an interview if you go to any type of coding job that involves object-oriented. Now you know. One thing means many things. Fine. So let's go about testing this code. I'm just going to drag this back into this window. I'm going to go back to our terminal. I'm going to make another file. I like to usually call these driver or main.cpp. Driver.cpp. And now we need a way to include the header file. Even though we've already defined what our class is in descriptive.cpp, nothing else knows what it is. So remember, a program and a computer on its own is very stupid. Now I can say, that's a table, and I don't need the instruction manual for that. But a computer doesn't know that. A computer says, give me the instruction manual. I want to see what the heck this table thing is if it's not built in. So what we need to do is we need to include descriptive.h. Now we can work with descriptive. We can start working with our table and we can do things. Great. Not exactly though. We need a main function. And the main function, if I didn't describe this well enough, was a function we need in every single one of our programs, but only once, and it's the main entry point of our program. So let me just make a main function. Int argc char star argv plus u. If you don't put these arguments, that's okay. If you don't, and if you don't include this, that's okay. It looks nicer if you do though, and there's a reason these are here. We're not going to go over that though. Now, let's go about making things happen in our main function. What do we want to do? We want to make descriptive right now. We want to go about printing the results. So let's make a version of descriptive. So we're going to have descriptive right here. It's just like any other type. So if we had an integer, we're actually going to make an integer, int, we're going to call it something, number equals 5. What we've just done here is we made an integer, and we've set it equal to 5. What we can do now is that we can make a descriptive, which in hindsight is a really awful name, and we're going to give it a name, what was it? Thing? No. Oh my god, I'm hurting myself with this. Thing, and we're just going to give it our number, the number we just made. So what did this just do? We just made a new class, a new object called descriptive, a new object of descriptive called thing, right here. And what we did was that we set this number, this one right here, equal to the number we just set in here. Fine, easy, not too shabby. Now we just want to go about printing this. So, in order to print things, we need to include our library, iostream, inoutstream, iostream, and I'm also going to include this convenience line, so using std cout, so standard cout, and then I'm just going to start, I'm also going to include our end line one as well, std endl, and now I'm just going to print what was inside of it. So we're going to call cout. This is called the stream extraction operator. Stream insertion? I don't remember. I'm going to say stream insertion. And anything you put after this is going to be printed. So I'm just going to put these two quotation marks. These quotation marks refer to a string. It means we print things from them. So we're going to say descriptive, actually it's in lowercase, descriptive number. Now if we want to reference any variables after this, we need to do two more of these. We need to then type the name of our class, thing, and then we're going to do something called use the dot operator. Dot. Now that we use this dot, we can reference any public methods or public variables inside of our class. So now that I've done this dot, it's opened up a whole new world. I can now access all of these functions. This one, literally all of these right here. It's just one function, by the way, in case. No, I'll try again next time. So thing dot get number. What we've just done is we've called a function. We've called get number from the class descriptive from this one object that we just made. I'm just going to end this line. And now we're done. We can test. I'm also going to have this return statement. Not necessary, but nice. So let me run this code. So in order to run our code, we go into our build folder, cd into builds, and we run the command cmake ... Enter. If you don't have cmake installed, you run the command sudo apt install cmake. Oh, it's going to want me to put in my password. It's already installed for me though, so it doesn't matter. Now that we've run the command cmake ... we need to run the command make, and I have an error. Now we can see that there's an error here. I don't make mistakes. My code is flawless just like myself, but occasionally I get distracted by my class, so it's your fault. So let's look at error parsing. What did I forget to do? Well, it seems like I was in a rush when I was making this, and I happened to forget a semicolon at the end of my constructor. This gives nice error messages. So we can go back, and we're going to go back to descriptive.h, because if we look here, it says this is where we have the error in the file descriptive.h on line number 7 and in row space number 23. I don't know. We go to the 7 thing, we go 23 spaces out, and we're going to put a semicolon, and it's going to work. Now my code is flawless. We run the make command again. Beautiful, look at that. Exactly what we need. Even though it's red, that means red means go. So we're going to go into our bin folder, and we're just going to run /. Hello world is what this is called. Bam, look at this. Descriptive number, and it's 5, just like we made it. So let's extend this. Let's make this even cooler, because we can. And we have that time. You people should know how this works. So we have our basic class. We can make this a better class. Because descriptive, it's kind of a boring class right now. Why not make it even cooler? We can do that. So let's make another function. This function is going to be called... I'm going to call it run. No, we're not going to do setter. Well, actually, do we want to do setters? Actually, no. Before we continue, are there any questions so far? Have I steamrolled over any questions? Go for it.
In this whole process, we've used 3 different files.
Yes.
What are the names of each? So we have a header file, we have a C++ file.
Mm-hmm.
What's the third one? The one you said?
So this get back here. This header file is how we define our class. Sorry, it's how we declare our class. This one tells you what is going to be inside the class, but it doesn't show how it works. Then we have a C++ file that goes with that header file. This one shows how it works, but this is the wrong one. This one shows how it works, but it doesn't have a nice layout so you can see everything at once. And finally, we have our last C++ file. This one has no relation to either of these 2 files. This file just goes about using things inside of that class we just made. Okay? Does that make sense?
Yep.
Okay. I saw another question. Go for it.
Does the constructor name have to have the same capitalizing as the name of the class?
Well, let me. I already sort of answered, but let me ask you this: if I do number equals 5, 6, did I just overwrite this? No, they're different. So C++ is a case-sensitive language, as are most languages. So it has to be the exact same case. It has to look identical to the name of the class. So the class name does not need to be the same name as the file name, although it really, really should. But once you make the class name, your constructor has to have the same name as your class name. You're going to get an error if you don't. This is how C++ knows that this is a constructor and not just a random function. Any other questions? Go for it.
In the main, why doesn't that have to be descriptive, colon, descriptive?
So we are not defining how these work. What we're doing is we're using them. So if we were going about defining these, if I wanted to do descriptive, and this is awful practice, but I could do this. If I wanted to do descriptive and get number, now I can make it do something else. 16. It's going to yell at you because you have two definitions of it. But if we got rid of this right here, now it's okay. The only time you need the two colons, get back here, is when you're going about defining things, or when you're referencing things from certain other classes. When you're using the standard template library, we'll get into that a bit more. And if you notice, we do this right here for other things in the standard template library. If I didn't include this convenience method, I would need to do standard cout. This is special because it's built into C++. That's the only reason why we have to do that. Does that answer your question? Okay. Let's move on. Let's give this a little bit more power. Descriptive should do awesome things. Wait. Questions? No more? Good. Okay, let's give it more power. We're going to give it a setter method. Now we want the user to be able to set our number. But maybe we don't want this number to be negative. So let's define a setter. So this is going to be void. Void means there is no return type. And we're going to call set number. And this is going to take an integer as an argument. Int. And we're going to call it input again because it's just nice and easy to call it that. Now, we need to go into our C++ file. And we need to set what this means. So I'm going to do that. Void. This is a return type. We need the name descriptive. Colon. We need the name of the function. This function name is set number. This is going to take one argument. It's going to be an integer. And now we can define what it does. Now, here's the thing. I really hate negative numbers. If someone were ever to put one of those as a grade for me, I'd get very angry. And in fact, descriptive hates negative numbers too. So we're going to make it so the user can't set a negative number. So what we're going to do is we're going to make it so that if input, let's do that a little bit more slowly. If, we're going to use a conditional. If, and inside here we check something. If input is less than 0, what we're going to do is we're just going to set the number, this one right here, to 0. Number equals 0. Otherwise, or else, we're going to set our number equal to what the user gave. Does this make sense so far? Yes?
Small thing. What's the difference between the else and the else if?
Else if, so when you're running a chain of conditionals, if you do if, and then we'll do thing, and does stuff, and you do another if, thing 2, and also does stuff, what's going to happen is that it's going to run this conditional right here, and then it's going to keep going along, and it's going to go along, and it's going to do this conditional right here too. Alright? If we have an else, then if this one is wrong, if this is false, it's going to run what's inside here in this else. Okay? Now let's say we only want to check this, and if this is right, we don't want to check this too. What we're going to do is we're going to write else if. Now what's going to happen, let me just format this so it's pretty. So pretty. Is that we're going to check this. If this is true, we're going to skip this one. And we're also going to skip this one. But if this is false, I'm going to finish prettifying it. If this is false, we're going to go to this one. And it's going to do this. And it's going to skip this otherwise. And if both of these are false, this is sort of the default. The else is the default statement, okay? That's why you don't have a condition with it. Does that make sense?
Yep.
Cool. Let's jump back to what we were doing before. And so can anyone tell me what's wrong with this logic? Why was what I just did really bad with set number? I never want the number to be negative. What did I do wrong? Let's scroll up a little bit. Is there any place the number could be negative? The answer to that is definitely yes. Ready? Let's go back to our driver function. This is our main function. What if I go about making this number to -1,000,000? I can do that. So, let's actually run this so you guys can see. And make, what did I do? Unused variable number, it's just giving me a warning. You can ignore that. cd bin and /hello world. Look at this, the descriptive number is -1,000,000. It's worse than like -1. My grade is dead. So, we need to make it so that when the user inputs a number, we double check that there too. This is the idea of not type safety, of making sure that input is always good. So if, I'm just going to do this quick, if input, not include, input less than 0, and we're going to set number equal to 0. I'm going to put this in an else, and put this here. Cool. Done. I can't set it to -1,000,000. If I run it, I'm going to run it. Bin and /. Now the number is 0. Yes, go for it.
Is there any way to cut that repetition?
Yes. So if we wanted to cut this, and this is smart, we're following the once and only once principle, what we could do is we could do this, and then we could do this. No, we don't even need to do that. I'm sorry. We can just call set number and type in input. And this is going to do it for us. Let me just run this. Make and cd bin, and then we can call /. And this is the same thing. So if we have logic in our setter function, that's exactly the same as a constructor. We can reuse that. And this is great because that gives us code reuse. Starting to run out of time, so let's do this last part quick. Just so I also have other things about inheritance up. We don't need to talk about that too much. It's going to be more of next week, but next week. But just so we know. So let's make our cool extra function. And I'm going to call this one run. So void run. And I'm going to define what run does here. So void, and it's going to be called, we need to do our descriptive name, run. And then we need to define what this does. What do I want this to do? I want to loop through this number, and every time the number is greater than 5, I'm going to print out the word hello world, because why not? So I'm going to use a for loop for this. So actually, let's do this one by one. For into I equals 0. What this does is we just initialized a variable, I, and set it to 0. This is a standard counting variable. The next thing is a conditional. We check every time the loop goes through. I greater than 5. Oh, sorry. No. I don't even need a while loop because I already have the number. Undo. While number. No. Hold on, I'm losing myself. Give me a sec. Okay, we have our for loop. I is going to be equal to the number we set. Number. While I is greater than 5, we're going to subtract 1 from I. This is short syntax for making subtract 1 from I. Minus minus or plus plus or whatever. Alright, the reason we don't want to set this to number is because we're actually going to subtract things from number if we do. And if we do that, number is going to be changed forever. So now, we have our condition. We're going to cout, and we're going to print hello world and endl. I'm not including a namespace for these, so we need to do standard and we need to standard. All right, let's bring this back. And now we have our run function. So let's go and let's run this. And we're going to set this to a number that's greater than 5 so we can run it a couple times. Let's set it to 15. Let's set it to a countable number. Let's do 10. So it'll do this 10 times. Yes. And we're going to run thing. We're going to do this by, we have our name right here. Thing.run. Let's run this. See if it works. Now I know it's going to work. But I know this is going to work. As I have a typo. No member function in class descriptive. So let's look at this. Let's debug. Why did this happen? Why is this wrong? So let's go back. We have void run. And this is in descriptive. And the answer to that is because I didn't save my file, and I do that all the time. So let's go back and let's build my file, because I know it's going to work now. What did I do wrong? Oh my god, I didn't include the libraries. This is a mishmash of me messing up. Include. Does anybody remember what we include when we print? Yeah. It doesn't know otherwise, because we didn't include the manual. Let's do it again. There we go. It's angry because I didn't use the number 5. We don't care. So let's cd into bin, /, and look at this. It prints out hello world 5 times just like we told it to. Computers are so nice. They just do what they need it to be done. And not a single thing more. So make sure you tell it exactly what you want it to do. That, friends, is how we build a basic class. Are there any questions about building a basic class? Yes? We're going to talk about that when we talk about copy constructors. But the idea behind it, I can talk about it now. Why not? When we have a postfix operator, I++ versus ++I, these do 2 different things. Now you seem to know what these are. Explain. What's the difference?
So I++ does the action, then it prints the counter. Well, ++I prints the counter, then does the action.
Right. So, think about for a second what this one needs to do. What it does is that you do the thing with I, then we add 1 to it. But how would you implement this if you wanted to? What you would have to do is that you would make a copy. So we're going to do void, and we're going to call this prefix. It's going to take a number, int. And what this is going to do, we're going to have a member variable called number. Counts. It's going to be equal to 5. What we need to do now is we need to copy counts into a temporary variable. Copy count into a variable, call it temp, int tmp equals count. And then we need to add 1 to counts. And then we need to return our temporary variable. Return temp. Comparatively, this is postfix. Comparatively, if you have a prefix implementation, int prefix, int num, what's it going to do? It's going to return count plus equals 1. Because of that, this operation is significantly less expensive than this one. It takes a lot less to do because you have to copy this to another variable, you add 1 to your member variable, then you return the copy. And that takes a lot of work. This one, on the other hand, is a single operation to return it right then and there. And I'll get my marker. Okay. You're always going to want to try and use that. Now, most people are going to say the compiler is going to optimize it for you. That's valid. It might. But what if it doesn't? Why not err on the safe side? May as well. Okay. Any other questions? Cool. Let's talk about inheritance real quick, and then you can be on your way. So, inheritance. LibreOffice Impress. Do you want to start? Why are you? Oh, because I already have it up. LOL. Let's talk about inheritance. Whatever. I talked about our class hierarchy diagrams the other day. We have maybe vehicle. And then we want to reuse code. Because a car and a truck both have wheels, even though they aren't the same thing, we can say that they have wheels in vehicle. So we can have two, we can have a car, we can have a truck. But you don't just buy a car, you buy like a Mercedes-Benz. As you're an engineer, may as well. So you have Mercedes, and if you're gonna buy, maybe you got like an Audi, I got a spare one in my garage. And then if you're gonna buy a truck, I don't know, maybe you got like a Ford or something. I don't really know cars, you probably know that by now, or like a Chrysler. There we go. And what's just happened here is that we have a lot of shared code now. Trucks, these two types of trucks, share a lot of things, but they aren't the same. So we have to define them differently, but why not make it so that they use things that are already a truck? And why not make them things that already use vehicle? Similarly enough, a Mercedes and an Audi are both cars. Therefore, they should use things that are similar to the car, that are similar with the cars. And finally, they should use things that are similar to the vehicle. This way we're able to group things categorically, and it's very easy to understand. We do this using a property called inheritance. And in C++, inheritance is like this. So let's draw what this would look like. Oh, we got like 6 minutes. Time runs short. If we have a class called name, then we're going to have some names after this. We're going to have me, but I'm different from Becky. And I'm most certainly different from Marty Meehan. Not as cool as me. So, this way, what we've just done here is that we have a new class. It's going to be named Darian, but it's going to take all the attributes from name. Because why not? And this is the basic idea behind inheritance. Now, you don't need to worry about this. Oh, it's a way of reusing code and keeping. I had another mess up my animations. It's a way of reusing code at the same time, while also keeping your code nice and organized. So other people, when they go about reading this, they can use it on their own. There are a lot of things I could talk about with inheritance, which is why we're not going to talk about them at all today. And you don't need to worry about this unless you're doing the Gamma assignment, so don't worry about it too much. But just know this is what inheritance is, and this is what you're going to need to know eventually. Inheritance is a big part of object-oriented programming, and it's something you're definitely going to want to know later on. All right? Question?
It has everything public from name, right?
No. It has. So there's also another modifier that we didn't go over. Actually, let's use our program. Let's use Sublime Text so we can get our cool little highlight. There's another field I can make. And this one, protected. Ho ho! We got a new one. What goes in here? Anything that inherits from this class can use protected data members or protected functions. Private is only for that one right there, though. Nothing else can use private methods. Unless you have a friend class. We're not going to go into that either. Not just yet. There's always an unless. There is absolutely nothing absolute ever in programming or in the entire world. Absolutes don't exist. So, just know if I say something absolute, I'm a liar. It's not a thing. All right? Any other questions? Yeah, go for it.
Private things can't be used by the classes that inherit from them.
Correct. They can use protected, though. And they can use public. However, if I go and I make a int cool thing, it can only be used by classes that inherit from. So if I try and go into driver, and I do thing dot cool thing, first off, I'm going to print this out actually. It's going to give me an error. And what it's saying is that it's just not going to work. It has no member cool thing. Of course it doesn't. Because it doesn't see it. It can't see it. It's protected, and it doesn't inherit from this. So it's not going to work. So that's the idea behind protected members. This is a way of giving yourself a little bit more fine-grained control when we're working with inheritance and all that. Okay. Any other questions? Okay. Class dismissed. That's all for this week. Enjoy the rest of your Monday. And enjoy your long weekends. It's already a week. It's going to be 2 now.